Hello, welcome back to Blender Sushi Live Noding. In this episode, I'm going to share with you this Sverchok Node 3, basically to create this kind of Suzanne orbiting planet kind of simulation. So you have like one big head of Suzanne, and we have another Suzanne head kind of rotating around this big one. And you have the smaller ones kind of rotating around this Suzanne head. So I think this is kind of an interesting example, and it can teach you a couple of things about doing some kind of matrix constraint inside Sverchok or using nodes. Um, it's kind of tricky at some point, but I'll show it to you that it's not that complicated, and perhaps this is something that you want at some point. The effect is almost like at first it seems like it's like when you are a parent doing like a parenting of objects, but this is more like a, I think, more like a constraining. So I'm gonna save this as Suzanne orbit, and let's turn on Spreadshop and start with something. So I'm gonna be using a Suzanne head. So we have Suzanne nodes. Let's save this, and I'm gonna be using viewer draw. Plug this into that guy. So this is a single Suzanne head. Turn off the points, and now let's create some kind of matrix there. So it's gonna be like first of all we're gonna use one matrix. This is a matrix in nodes to create like a transform kind of data. So we plug that in, and with vector in for the locations, you can move Suzanne in position. For the first Suzanne head, it's gonna be in the center, so we're not gonna be moving it. So keep it like that, and we can scale it if you like, but we don't need to scale it for now. We're just gonna be rotating it like that. So that's gonna be the first frame, goes into the angle, and here we can of course make it faster or slower simply by using a multiplier. So make it like 5 times faster. Okay, a single Suzanne head rotating. So how do we make the second Suzanne head? So the idea here is we're gonna take advantage of vectorization here on the matrix. So we're gonna be like using list join. We're gonna, if I just gonna duplicate this guy and this guy, join together like that, hopefully we're gonna have two Suzanne head. So that's actually the advantage of Sverchok, right? You already know on this, you can have now like two Suzanne head rotating at the same time because they are using the same speed, but I can make the other one a little bit faster. So this one twice faster than this one, and I can change the scaling. Second one is a bit smaller, which is, I found kind of interesting, but it's just like a two rotating head. If the smaller one kind of being parented or kind of more like orbiting the big one, and then it's gonna be more interesting. So let's see how we can do that. It's not actually that complicated. You just from my experiment, basically you just need to apply the vector, because we have a single vector coming from this guy, right? So we need to somewhat assign this guy right here, and this vector goes in there, which is the offset, and then this location goes in here. So now let's see what happens if I'm doing this correctly. You see, it's like the small one is kind of like rotating with the big one now. If I make the speed the same, it's almost like a like a clock. Something is moving backward. I can actually rotate the other one like in reverse. So now it's almost like a gear. it's rotating in the opposite direction, and now it's actually starting to look more interesting. It's almost like a bit like dancing. So let's save this. This is starting to get interesting. Let's see if this guy actually 4 times faster in the opposite directions. Now it's almost like even though the small one is kind of rotating with the big one, it's also doing its own thing. That's actually making it more interesting. So let's make another smaller Suzanne. So now it's getting slightly more complicated, but basically the idea here is we have a single frame info coming in, and we have some kind of variations in the speed of 2 Suzanne. But the one that's doing the interesting part is this matrix apply. So I didn't know. I found out about this by try and error, and this actually makes a bit of sense. Interesting kind of result. You can keep doing this for multiple Suzanne. So like I said, this is the offset. This is the original one. And then so we're gonna need to offset again, and then this is the matrix going in, you know, from the parent going down children and going down again. In this case, I found it's less about parenting. It's more like a kind of the small one kind of being oriented to the bigger one, which is kind of more interesting. So now we have another more interesting animations here. See, I can still control the offset first of all. So the smaller Suzanne, I'll make even smaller. So now we have big Suzanne, and then there's this medium-sized Suzanne and this really small Suzanne, and they are all rotating. And for the smaller Suzanne, I will also do this multiplier thing. So multiplier, just for the multiplier, I just make it closer to the frame so it's easier. So because we have 3 Suzanne. So now the smaller one, let's make it go in the opposite directions, and it's rotating in the opposite directions basically. I'm pretty sure that perhaps at some point, if you want to make some kind of variations here, we can also use matrix deform. That's gonna be like an extra layer of surprise. See, currently it's almost like this one being parented to this guy, and then the smaller one being parented to the medium one. But you can actually use a matrix deform, if I'm not wrong, and then here you can actually do some unusual rotation. For example, I'll keep this rotation 001 in the z-axis, and then the float, put it there. Let's do it like this. This is the frame, goes into the angle. Currently not very interesting yet. I'm checking whether this deform actually working. So there's this deforming. Yeah, see now it's looks like the little one is rotating differently because of this matrix is deformed. But I'm not gonna do that. I think it's a little bit complicated for now. So you can have this 3 Suzanne. What's even more interesting is that you can go smaller here. That instead of using a single offset value here, vector offset, we can use multiple. I'm gonna use 5 random value goes in there, and I'm gonna spread it. So we have actually now 5 smaller Suzanne orbiting around this medium one, which is I found quite interesting actually. So this is like a 3 levels of matrix transformations and happening on the Suzanne head. I think it's quite not very easy to understand, but very interesting. For the rotations, you can actually have multiple as well. So so vector in for the rotations, but then you give it a different random value between -1 and 1. So it's got, some is gonna be rotating faster, some is gonna be rotating slower. See, now they're all orbiting on it around the center of itself, while also orbiting around this guy right here. Probably can randomize the speed as well of rotations, but they're all rotating around. Would be nicer if the little one actually rotate around this guy right here, kind of like making like a ring. Currently they're not really making a ring, but there you go. That's some kind of Suzanne planet rotating orbit simulations. You can change the Suzanne head with anything. Basically, if you go to the top, currently we have Suzanne, but you can easily use like a box, for example, and now the whole simulation is gonna work differently. See, it's a lot faster as well. With Sverchok, it's really because it's like a modeling tool, but I'm using it for animation as well. It's like sometimes it's better you bake it or you use like a different method, you know, like to make animation a little bit faster. So yeah, something like that's kind of interesting. Yeah, anyhow, this is pretty much it for this live loading. Sorry about the noise from the outside, and I'll see you next time. Thank you. Bye.